So question 7, we want to show this identity is true. And I'm going to start with the left-hand side just because it looks like there's more that I can do with the left-hand side. So my left-hand side is tan squared theta plus sine squared theta. And that's over cos theta plus sec theta. Now, it's not always obvious where you should go with these. So sometimes you just have to dive in. Well, I know that tan squared is sine squared over cos squared. And then that's plus sine squared theta. And I'm not going to change the bottom at the moment. And then I don't really like having this fraction on a fraction, so I'm going to multiply top and bottom by cos squared theta to get rid of that. So let's see what happens there. So on the top there, I'll end up with sine squared theta plus cos squared theta sine squared theta. And on the bottom, I would get cos cube theta, and then remember that sec is 1 over cos, so when I multiply that by cos, I'm going to get cos theta. And then on the top, I've got this common sine squared theta that I can take out, and then I'll have 1 plus cos squared theta in there. And on the bottom, I've got a common cos theta that I can take out. And then I'll have cos squared theta plus 1. And these brackets are actually the same. I've just written them in a different order, so I can cancel that. So I now have sine squared theta divided by cos theta, which is sine theta over cos theta multiplied by sine theta over 1, which is tan theta times sine theta, which is the right-hand side. Okay, well, there's a second part of this question. So we're given that x is equal to 3 sine theta and that y is equal to 3 over it's phi, 3 sine phi, and y is equal to 3 over cos phi. Find the numerical value of 9y squared minus x squared y squared. Okay, so once again, I think we just dig in and just substitute these things in. So we've got 9, 3 over cos phi squared, take away 3 sine phi squared, 3 over cos phi squared. Okay, so what's that going to give me? So the 3 squared is 9 times this 9, so that's 81 over cos squared phi. Take away, so we're going to get 3 squared out of there, 9, 3 squared out of here, so that's going to be another 81. And we'll have a sine squared phi, and on the bottom we'll have a cos squared phi. So that's quite nice. We've got the same denominator, so I think I can see where this is going now. We've got 81, take away 81 sine squared phi, all over cos squared phi. And that's 81 into 1 minus sine squared phi over cos squared phi. And of course, we know that cos squared plus sine squared always gives us 1. So the 1 minus sine squared is going to be cos squared. So it's going to be 81 cos squared phi over cos squared phi. Cos squared phi is cancel, and we get 81.